Now we take it to the next level and give some names to these things. The marginal probability on here and here, they have a special name that we are going to call them. We are going to call these as prior probability. So marginal is going to be referred to as prior probability. Okay, and this probability, conditional, will have two names. If we want to, our question mark or our dependent variable is here. We want to estimate about person has cold or flu. In that case, the conditional probability, this one, the probability that the person has cold, given that the person is not sneezing, it's going to be referred to as the likelihood. It is from our data, from 130 observations, what is the likelihood if a new person who comes in and the person is not sneezing, what's the probability that the person has cold? What's the probability that the person has flu? Given the symptom, we want to calculate the likelihood of diagnosis. So the formula that we have here is going to be used in terms of these two terms, likelihood multiplied by prior, divided by the marginal. We have two kinds, right? One margin is here, one margin is here. The margin that we call prior, it is about the dependent variable. In the margin we have here, it is about the independent variable, right? This margin, symptoms. We see symptoms and we want to answer whether, based on this symptom, what is the probability the person has cold or flu. So the prior that we are going to represent here is going to be referred to as total evidence. In the conditional that we have for given the symptom, what is the likelihood that, what is the probability that person has cold or flu, we are going to refer to as posterior. So 4 different names. Posterior is, for example, cold given sneeze, probability of flu given sneeze. So these two probabilities will be calculated by multiplying likelihood of sneeze given cold multiplied by probability of cold, and then probability of sneeze given flu multiplied by probability of flu. Can you read this much small text? Likelihood. These two conditional probabilities are likelihood. This is prior. How many people are having cold? How many people are having flu? So the priors we have on this margin divided by total evidence is on this margin. So the probability that the person is sneezing is divided into two numbers. People who are sneezing, some are here, some are here, right? So we will say probability of sneezing. They are total evidence. This is our prior. So can you easily map our concepts of marginal probabilities, joint probabilities, conditional probabilities to this formula? Here we have something which is referred to as Bayes formula. And it comes through our derivation here. Since joint divided by marginal is conditional, so joint will be marginal multiplied by conditional. And there are two ways we can look at this joint probabilities, from this angle or from this angle. And both are explained here, and we proved that both are equal, right? In that case, we can use this relationship in probabilities by calling the posteriors. So our question is whether, given the symptom, person is sneezing, what is the probability that the person has cold or person has flu? We will solve it by calculating the conditional that the person has cold. Given the person has cold, what's the probability person is sneezing? And given the person has flu, what is the probability person is sneezing? These are likelihood probabilities. Likelihood is conditional probability. Prior is our marginal probability. Here we see marginal, right? Marginal of having cold in all diagnosis, marginal of having flu in all symptoms, not diagnosis, in all symptoms. So cold can be both in case of when person is sneezing or when person is not sneezing. Flu can be in both conditions. So we have marginal probability to cover that. We refer to that as our prior knowledge. If we don't know the symptom, the prior probability tells us overall what is the chance the person will be having cold. We will go to these numbers, right? The total evidence, you can see for both questions, total evidence is same, probability of sneezing. Right? So if we calculate, we will see one of the numbers is probability of cold is, let's say, higher, given that person is sneezing, and probability of flu is lower than that probability, given that the person is sneezing. So we will classify the new person in the cold class. If the relationship otherwise, we will classify the new person in flu